Welcome to today's lab. We are going to be doing a calorimeter lab. This is going to be the way that scientists actually calculate the specific heat of different substances. The only difference is this is a much cheaper, jankier setup than scientists have, so our results might not quite be as accurate. So this is aluminum. So we can take a look at what its specific heat is, but we're going to try to calculate it by putting it in this water. I'm going to have this water be boiling at the time. We know that boiling water is 100 degrees. So after I leave it in there for a little while, we'll know that that aluminum will also be 100 degrees because they're going to come to the same temperature. And then once it's hot, I could remove it and put it in this cup of water and put the thermometer back in. And using the law of conservation of energy, the amount of heat that the metal loses will be the same as the amount of heat that the water absorbs, and we could use that temperature change to calculate the specific heat of aluminum. So then we could use that to compare to the real specific heat of aluminum to see how accurate we were. And then I have no idea what these metals are. So we can use that same process to find the specific heat of these metals and identify what they are. To quickly recap what we're doing, we are heating the metal up to 100 degrees and then dropping it in water and see how much energy that water absorbs. So what I need to remember is the law of conservation of energy, that heat lost by the metal is equal to the heat gained by the water. And that allows me to write this equation down here, where I have my specific heat of the metal times the mass of the metal times the temperature change of the metal is going to be equal to the specific heat of water, the mass of the water, and the change in temperature of the water. So we could start filling things in. I could tell you that I've already measured a couple of these things. And we already know some of these things as well. So let's plug in our specific heat of water, which we're just going to use as 4.18 joules per gram Celsius. And I can tell you I measured the mass of the water as well, 100 grams. So we just need to know the change in temperature. And then on the metal side, I need to go measure the mass right now. Let's go do that. So the mass of this piece of aluminum is about 17.5 grams. So we could fill that in as well. So now we just got to do the experiment. We can get the change in temperature, and that'll help us figure out, this is what we're looking for right here, our specific heat of that aluminum. All right, so we've been boiling the aluminum for maybe about 5 minutes now, so it should be 100 degrees. So that's going to be our initial temperature of our metal. We also need to take our initial temperature of our water, and I believe it should just be room temperature, right around 21 degrees. Let's take a look what it says. I think it says, oh, you know what? Maybe it's closer to 22 degrees. We'll put down 22 degrees for that. All right, so now it is time to take the metal out and put it in our cup of water. We want to do this as fast as we can because we want to make sure that all the heat is going into that water. And the longer we take, the more heat gets released into the area around it. So I want to have everything ready to do this as fast as I can. There we go. And now, all we got to do is wait and see how high that temperature goes. right now it looks so 2-degree climb. We'll see if it goes up any higher. It looks like 24 degrees Celsius was the warmest it got. So we're going to use that as our final temperature for both our metal and for our water. So we're just going to throw these in now. 24 degrees Celsius. And for our water, that went up to 24 degrees Celsius. Now you can do all the math here, and we're going to solve for our specific heat of aluminum. If you completed this, aluminum, as we calculated through our experiment, was about 0.63 joules per gram Celsius. If you take a look online at what the actual value is, I got a table right here. Aluminum, we move over to specific heat. The actual specific heat is about 0.9 in the range of that. So we are pretty far off, but that's to be expected because we're just using a styrofoam cup. So we got about, 0.27 off. So not too bad. Probably not good enough to help us identify any unknown metals. So, but we'll give it one more shot. I think in our next experiment, something we can do to get a more accurate answer is using less than 100 grams of water. So let's try to do that. We'll run through another one with a little bit less water, and we'll see what we get. All right, for this trial, All right, so for this trial, I've changed the amount of water I have in here. We only got 38 grams. So that might help give us some more accurate information. And the other thing that we got, we're going to be using this piece of metal instead. So let's get the mass of that metal. And then we could throw it in the boiling water and get it up to 100 degrees here soon. So this one's 83.1 grams. So let's get that in the water. All right, and we'll give that maybe 10 minutes to heat up. As that's going on, let's plug our numbers in so we can get started with our math. So again, we're going to be looking for our specific heat of this metal. Hopefully that'll help us identify it. It's not always the best way, especially with this method, but maybe we can get an idea of what it is, and maybe definitely an idea of what it's not. All right, so we got our mass, which I'm going to... All right, so we got the mass of the metal now, 83.1 grams. And then we got to have our temperature. We know our initial temperature is going to be 100 degrees because it'll be the same temperature as that boiling water. We just need to figure out what that final temperature is. That's what the measurement we're going to be taking. And that'll be equal to our specific heat of water, 4.18 joules per, a nicer 8 there, 4.18 joules per gram Celsius. The mass, which we said was 38 grams this time, which can also give us a more accurate answer if we got less water here. And then we need our change in temperature. So our initial, and we can go take a look at that right now. You know, the last one, you know, was 22. Maybe it was between 21 and 22. We put 22. Let's take a good look at this one. Looks like it's at 23. Maybe we'll come back and take this measurement right before we drop the metal in. All right, so it looks like the temperature's lowered. Looks like it's closer to 22 degrees Celsius. So we're going to use that as our initial temperature. And it's been boiling for quite a while now, so I think it's time to put that in our calorimeter and see what temperature it goes up to. So I want to do this as fast as I can. I want to make sure I don't break my thermometer either, so let's bring that up. Well, I'm going to leave it in there. I'm going to make a fast transition. And then all we got to do now is wait till see what the temperature goes up to. As we see here, just 22 degrees that we started at, which is already a much bigger temperature jump. Oh, look at that. Still going up. It's at 33, maybe it'll get to 34. So this bigger temperature jump should give us some more accurate data as well. So that's exciting too. So we'll just wait as it keeps going up. Looks like it's at 34 degrees. So been waiting here a while. Any warmer than 34 degrees. So that is going to be our final temperature. Now we can throw everything into our equation and see what our answer is for our specific heat. Then we could identify the metal. So I'm not sure if one of my videos recorded, so I'm just going to say what we found out. Our initial temperature we found was 22 degrees Celsius. And now we could plug in our final temperature, which for both the metal, 34 degrees Celsius, and the water will be 34 degrees Celsius. And one thing I didn't include last time, I forgot this, is that remember that metal is losing heat. So this is a negative number and the water is absorbing heat. So that's a positive number. So what should come right here is a negative, but don't worry too much about it because the signs will all cancel out. And our specific heat is always going to be a positive number. So that's also an important thing to remember. Just in case, like me, you forget that negative here. Should be here as well. All right, so let's do the math now. We got all the numbers, and let's calculate our specific heat. All right, so by doing these calculations, 6 joules, we divide it by these numbers we got on this side. And our answer comes out to 0.35 joules per gram Celsius. And again, we could take a look at a table, just like this one. And the closest is copper. I can tell you it's not copper right now because of the color, but other ones that are pretty close could be iron, could be nickel. I'm not rich enough for it to be silver. So it's probably iron or nickel. And they have very similar specific heats. So in order to find the actual identity of it, we'd probably have to do something like density. And you know what? Might as well do that right now. Let's figure out what it is. I'm curious. So let's see. We got to take a look at these densities, and we'll calculate that right now. To find density, we need our mass and our volume, and we already have our mass, 83.1 grams. So because this is a nice, perfect cylinder, I was able to measure with the ruler, got our volume right here, and just had to divide those two numbers to get a density of 7.7 grams per milliliter. And that is by far closest to iron. My guess, you could see it's a little bit rusted, might have some other stuff in there, but my best guess is that it is mostly iron.